Hello, this is an introduction to 3D printing, dental 3D printing, how to start and what to consider. And I made and have given this presentation in a couple places, and I really made it to be as unbiased as possible. And for anybody that is looking at adding a 3D printer to their practice, dental laboratory, or maybe adding a second one or moving to a different technology. And so there will be some specifics to Formlabs, but I really try to make the majority of the recommendations and content in here just as unbiased and, in my experience, useful as possible. So let's get started here. So I'm going to do a quick introduction. I'm going to highlight some of the most common types of 3D printing, a short history of 3D printing in dental. Then I'll go through the entire digital workflow using 3D printing in dental, so the front end and the back end, as well as the 3D printing. The production and benefit concerns, production and business concerns, the cost of 3D printing and going digital, because you do need so there are some prerequisite pieces of hardware and software, and then finally the dental applications on our Form 3B and a bit of a conclusion. My name is Sam Wainwright. I'm the dental product manager at Formlabs, and I've got 10 years of experience in the industry, and I started with 3D printing in 2008 with a large format SLA printer. Really quickly, a little bit about Formlabs and Formlabs Dental. Formlabs was started about 5 years ago by a couple MIT graduates, and started a very small company with a Kickstarter, and since then we have become one of the biggest 3D printing companies in the world with over 500 people and 7 office locations around the globe. Formlabs Dental is a business unit inside Formlabs that is completely focused on the Form 3B, Preform, and other hardware, software, and material solutions to work for dental and meet our high demands, the workflows, the software integrations, and of course the materials development and many other things. So really we're the rubber that meets the road for dental and Formlabs. To get this thing started, there are 3 most common types of 3D printing. There are other 3D printing technologies, but these are really the ones that you will run into when researching 3D printing. The first one is photopolymerization. This is really, the materials are thermoset plastics, and the technology is most commonly referred to as SLA. It was actually invented in the 1980s, but really what it is it takes a liquid resin, and that resin solidifies when exposed to UV light. The second one here is laser sintering. It is for metal and thermoplastics like nylon, most commonly referred to as SLS or SLM. But this is a really amazing technology that uses a laser to actually melt metals or plastics into shapes. Lastly, extrusion, most commonly referred to as FDM, the most affordable way to 3D print and fantastic for hobbyists or kids because the thermoplastics they use are very safe to handle and interact with. Very amazing technology in FDM as well. To start here, a little bit more detail on photopolymerization. Really, there are a couple different technologies for this process. SLA, LFS, DLP, and LAD are all fundamentally the same thing. All they really do is it's about getting light to the resin and solidifying it layer by layer. There are a couple other technologies called jetting and polyjet. They were actually very big in dental 5 or 10 years ago. The brand names are ProJet and Objet, but it is a bit different than these other technologies, and I won't be talking about that today. So these SLA technologies, DLP or LED otherwise, fundamentally what they do is they put a build platform into a vat or a tank of resin, go down to the bottom of the tank, which is translucent, and then a light source, a laser or a projector or what have you, projects through that tank, and the part is cured layer by layer. Here's an animation and a side view of the technology behind the Form 3B. Like I explained, the part is suspended above the clear tank a certain layer height, so let's say 50 or 100 microns. The laser moves across and solidifies the part of the object that need to be printed for that next layer, and moves up and down until the part is done. Some technology differences between really DLP and LED versus SLA and LFS, which is our technology, is DLP and LED are based on pixels. And just like a 1080p screen that you could be watching this video on right now, there are only a certain amount of pixels that it can use. So that's why you'll see most of the popular dental printers using 1080p projectors. The build plates are very small. And if it's that same type of projector and it is a much bigger build plate, they're sacrificing pixel size. So they could be making that pixel, instead of 65 or 85 microns, maybe 100 or even larger to get that extra size in build plate. And I will say that DLP and LED has a huge advantage over being able to project the light on the full layer that it's printing, allowing it to be much faster, but it is really dependent on the pixels for resolution and surface quality and so forth and so on. There are other interesting technologies like anti-aliasing and other things, but really it's a limitation of pixels. SLA and LFS moves a laser across the part, and the spot size on the Form 3B is an 85 micron diameter circle, as you see here, and the control that the printer has to move it across the part to make an edge is 25 microns. So as you can see in the image here, when you make an edge of a smooth surface in organic geometry like a tooth, you can get much smoother, finer details just due to the nature of the technology. Now, since it is a laser moving, it is a bit slower than technology like DLP, but that is just, again, due to how the light is moved around, being one point moving very quickly versus an entire layer being projected. Laser sintering is, like I mentioned before, can make metals and thermoplastics. It's most commonly referred to as SLS or SLM, but this is incredible technology that actually the parts are encased in unsintered powder. So the parts are actually going into the powder as it prints, and a roller rolls over the next layer, whether it's, say, 50 or 100 microns. But the incredible part about this is the parts have no supports on them because they're suspended in the powder, and the materials, to be able to print metal and nylon is simply incredible because they have a ton of possibilities to them. This technology is very, very expensive today, and I think there's a huge potential for it becoming more affordable in the future as the technology becomes mature. But very, very cool. And just as an example here, Argon, who they have a milling center and they sell CAD/CAM products. They use SLS technology to make their non-precious and semi-precious copings and frames, so they don't cast, right? They're printing them directly and finishing them up. Very impressive operation, and the printers they're using are extremely expensive, and the maintenance and the skill set that you need to run them is pretty immense. Last one here, extrusion technology. It's most commonly referred to as FDM. Think of this as like a hot glue gun that's computer controlled. It feeds a wire or filament through a heated nozzle and actually lays down the parts layer by layer. One of the fantastic things about this is, since it is a thermoplastic, plastics that can be heated up, and as they cool, they become hard again. It's very good for kids. It really is very, very affordable to get into this technology, and really what I think anybody that is just curious in 3D printing outside of dental should consider for their first 3D printer. There are some major limitations for dental use, such as accuracy, surface quality, and many other things, but super, super cool technology. And I think all three of these technologies have a space and a use. Just a picture here, this is an FDM printer, the Ender 5 Pro. This is the one that I would recommend to anybody looking at this technology. It's very easy to use, affordable, and very, very cool. Something else that's really neat is that on a bigger scale is they're now using extrusion technology to 3D print buildings. So they have liquid concrete, and they use a computer-controlled arm to lay down the parts of the walls and the features of the house, and workers move around and lay in the re-rod or whatever it might be. But this is an incredibly interesting technology and usage of the same technology or the fundamentals of FDM. So very, very cool stuff. Next, I want to go over and talk about a short history of 3D printing in dental. Really, there are 4 milestones I'll be talking about. 2000, the earliest for 3D printing in dental, really to note of, and the breakout success of a certain company. 2005, digital impressions for an analog world. The first 3D intraoral scanners are coming out. 2010, laboratories fully find their digital sort of path with all ceramic restorations, desktop scanners, and CAD. They go mainstream. And then in 2015, the dental 3D printer boom. So to start in 2000, a small company named Invisalign was founded in 1997, and they really pioneered clear aligners through sheer force and marketing and clinical studies and everything else. But they, just a quick high level on the process, if you don't know it, you take an impression. The impression gets digitized. They use their incredible technology to design and make the case plan. Something to note here is if, say, there's 10 steps or treatments to it over 10 months, they print 10 models to thermoform. So the design software you design to your final form, and it outputs the steps appropriate to the movement of the teeth. So here's an example of the initial smile to the final smile. And Invisalign is actually the largest user of 3D printing in the world by a long shot. You can see here this is a huge right side up SLA printer that they use. I believe it's from 3D Systems, and they produce an incredible amount of models. They actually make, I believe it's over 300,000 horseshoe arch models a day. And this is not Invisalign's imagery here. This is actually something from Formlabs. But fundamentally, what they're doing is they are thermoforming over all these models, and they have automated CNC machines that cut out and trim the parts, and then they go through final QC. So fundamentally, this technology, thermoforming and everything else, is the same thing that somebody could put into their office with one of these new modern dental 3D printers like the Form 3B. It's really super fascinating, and these thermoformed plastic sheets have incredible materials characteristics that we probably will not see in 3D printing in the near future, but I could be totally proven wrong. So here's the sheet as it's formed over the part. This is actually a pressure former, a really great the Druformat. It's fantastic. You can see here the anatomy is fully formed. The Invisalign factory is absolutely incredible, but the entire process has been automated as much as possible. Like I said, it's over 300,000 models a day, and then once the aligner is QC'd and finished, it goes into the individual packets for each step of the process or month that the patient wears it. And something that's really interesting, it might be the most used case of 3D printing in the world, but the patient never sees a 3D printed part. They only get the aligner and never the model. So it's really probably pretty unknown to the public in general. And this slide actually should be updated. It's actually 350,000 aligner models per day. And one fun fact is once the aligner model is used by Align, they're ground up and used for asphalt for paving roads. So they reuse the material in some way at least. In 2005, it was really the first non-CEREC version of 3D intraorals for scan coming out, like the Lava COS and iTero. And these were all coming to market very soon after 2005. And really why this is important for 3D printing is because most laboratories were not digital. They didn't have 3D printers at the time. And so what I actually worked for the company 3M, Brontis Technologies. What they had to do was they had to validate and make a 3D printed model that worked for an analog dental technician, so you could still make a restoration the same way. And we used, the printers were almost $500,000. The 3D Systems Viper Pros, really super accurate models, high, you needed an engineer to run it, a very high maintenance, but unbelievable print technology. And as you can see, the machine was absolutely enormous. But the Lava COS really, that we built a system where even if the impression is digital, it could still go through an analog restorative workflow, and that was really fundamental for 3D printing, and it had a lot of different parts to it. So we had to develop a margin marking software, and I'll just say I had very little to do with the development. I was very new in my career, but I used their software, the margin marking software, and I built the models and GeoMagic and all that. But in any case, so the custom software was built to mark the margins and view the images off of the camera. Once the margin was marked, we would build the model at our location right outside of Boston, Massachusetts, using a custom script in GeoMagic, and then 3D print the model. Simply incredible that it even worked at all. And I actually have one of these models still, and I pulled it out the other day, and it still fits, which is amazing that it didn't distort or anything. So simply incredible, very, very accurate. And again, it was making a digital impression analog, so a traditionally made crown could be made on it. And the fits and treatments worked incredibly well. So, and of course, 3D intraoral scanning has evolved rapidly since then. In 2010, this is really when laboratories really started adopting and seeing the future in digital, with the advent of all ceramic restorations and scanners. And one part of that was 3Shape and their desktop scanner to digitize stone models and design crowns in a way that just wasn't seen before efficiently, and you could start seeing some real labor savings. And a part of that was a pressable all ceramic product that you all probably know named Emax. And interesting point around this time, of course, was that gold prices were skyrocketing around 2010. So all ceramic options became very attractive in other ways. And so large milling centers and laboratories would start adopting 3D printing for pressing patterns, so burning out and pressing these Emax ingots. And so this is where PolyJet technology actually comes in. 3D Systems here in this picture uses PolyJet technology. They had this castable, burnable out material, and they would be sprued and set up in a ring and everything else. And they would burn out the 3D printed pattern. And really this made the digital workflow for the laboratory, scanning the model, designing the restoration, 3D printing the part, no hand waxing needed, pressing an all ceramic restoration, which was becoming more and more prescribed in the market. The per part cost is low. It was a big turning point for the dental laboratory industry, and while 3D printing these patterns wasn't a huge part of it, it was a part of it, and I think an important adoption point for the industry. In 2015, there was a dental 3D printing boom, and I really think the Form 2 had a lot to do with it. Before this, 3D printers in dental were over $85,000 easily. They're hard to use. The support was lackluster. I used to sell and use many of them in my previous life, and I think the time that it became viable for smaller labs in 2015 was with the Form 2. For $3,500, you could get an accurate, professional level 3D printing desktop that was easy to use. And since then, the dental 3D printing industry has been booming. So the Cara from Colzer, Carbon, Asiga, EnvisionTech, Sprint Ray, Bagos printer. It was just, since 2015, in the past 5 years, there have been so many 3D printers. And fundamentally, if it wasn't explained in my technology part earlier, these are all really similar technologies, but the core behind them, the workflow, the software, the materials, how it works, how reliable it is really the key to all of them. Really quickly, this is probably the least interesting part, but it's important to have a bit of context before I go on to the next parts. I want to go through the 3D printing process and workflow completely, and then I'll get into some of the use cases and other examples. These are the four main steps of making a surgical guide, starting with the scan and ending with the placement of that implant using the guide. Here's the final product, but first step, you need to acquire the data or the impression. So this can be with the traditional impression that's digitized or directly with the 3D intraoral scanner, like the one you see here. The second input for a surgical guide is a CBTC or cone beam scan of the bone density, so you can plan and design the case. Once you have those two inputs, you go into the CAD software. I'm showing Implant Studio from 3Shape here. You mark the nerve, you pick your implant type and size, and you set up and design the guide with sleeve and the how much of the teeth you want covered, how much retention, and all those things. So you design your guide based on the correct bone placement and everything else. Once that CAD software is done, you are ready to manufacture that guide and proceed to the procedure. So that's when 3D printing's workflow starts. And something that's really important here is pretty much all 3D printed products, 3D printers, these are all the same steps fundamentally. There are some differences with Formlabs or another, but really these are fundamentally the same high-level workflow, right? So you need to pick a material, you need to bring your design into the CAM software, in this case it's Preform, send the job to the printer, it prints, and then you need to post-process, which is washing an isopropyl alcohol and then UV curing. And again, all dental printers, if they are photopolymerization printers, have the same exact requirements in post-processing. So these are all applicable to, say, a Carbon or Colzer or whatever you might be looking at, or even you own. So this could be something that you're aware of. So first step is, this is Preform. You bring in your surgical guide, you rotate it so the intaglio surface is facing up, you generate supports, and then you send the job to the printer. Very easy to pick, if you have multiple printers, what printer you want, send the job, and it's waiting for you on the screen, or even we have the ability to do remote printing where you prepare the printer ahead of time and it starts the job for you automatically. Once the job has been sent to the printer, you pick out your material that you selected in the CAM software Preform. Our printer uses a cartridge system, so you don't have to pour or really handle resin at all. You put it into the back, and it disperses it automatically into the tank. That being said, you put the tank in, and then you put the build plate in. So those are the three things you need to do to prepare the printer. You click go on the printer, and it prints the surgical guide, or in this hyperlapse image here, these are actually splints, but hopefully you get the point. You are then ready, once it's done printing, to post-process. So the part is hanging from your build plate. You're then ready to wash and cure. I like to remove the parts from the build plate first, wipe the build plate, put it back in the printer, run my next job, and those parts are then covered in resin, and that resin needs to be washed off. This wash process, and I'm going to get into a little bit more detail later on some options here, but for our workflow, you use the Form Wash, which is an automated cleaning system. You set a time, say 10 minutes, you hit go. Once it's done, it comes out, which is great for being able to go to lunch and not have to worry about parts sitting in IPA. If parts sit in IPA, they degrade over time and they lose a lot of their material characteristics. There's also a little sort of deep fryer basket that you can put the parts in. This is what I prefer. You hit go and it washes the part for the set amount of time, and you bring it out and dry it. Once it's dry, you're ready to UV cure. The Form Cure operates very similar to the wash. You set a time and a temperature, you hit go, it rotates around, it cures the part, and you can just not worry about it, because once it's done, it just stops and waits for you. Here's the inside of the cure chamber. So that's pretty much the 3D printing workflow. Once it's UV cured, you're ready to post-process it, finish it, assemble it, and deliver it. So the parts come out, you remove the supports by either clipping them or just breaking them away. You can polish these surgical guides, not a requirement here, just got to make sure there's no sharp edges, just finish it down a little bit, but you can polish them as well. You insert the sleeve, which is typically friction fit. And then finally, right before treatment, you can steam autoclave surgical guides printed in our surgical guide resin. Lastly, there's some color differences in each step of the process. So once it's printed, cured, finished, assembled, and then autoclave, you'll notice that it turns back semi-yellow, clearish. So you'll know if it's autoclave visually, which is nice. Here's a bit of the hero shot, and then the procedure happens. So you're ready to do your place your implant. So that's the overall workflow for a bit of context before getting into the next parts of this presentation. So the production and business considerations are really, really critical here. And again, I'm trying to be as unbiased as possible here. Really, there are some prerequisites and some considerations for sure. So first of all, get buy-in from your staff. If you're a manager or an owner or a dentist, it should be a team conversation and decision. I see this mistake happen all the time, where the doctor or somebody gets very excited about something and they buy it, and then they expect somebody in the business to run it, and they are just shocked by it, and they're scared because their part of the business is going digital, and they don't know it. So make it a conversation. Technical skills, or probably more importantly, willingness to learn it and do it, is a must for this. This is the same for 3D intraoral scanning as well, or any digital technology. And really, if you're a practice or a lab even, right, a dental technician with digital experience and sort of a mind for this type of thing is always ideal if possible. For 3D intraoral scanners, digital impressions are a must in these workflows. So they can be a desktop laboratory scanner or a 3D intraoral scanner. Probably the most relevant, since most laboratories have scanners now, is 3D intraoral scanners. So some things to consider for a practice: these are expensive machines. Tissue management is critical. There's a learning curve to them. You have to consider and make sure that the scanner is open or is it closed. Most CAD softwares, they want STL files. You want an open system. And are you using this device for all cases? If you only have one and you have multiple operatories, and you're treating 2 patients at the same time, you might need multiple 3D intraoral scanners to do your throughput for the day, right? So consider all those things if you're a practice. If you're a laboratory and your doctor is buying a 3D intraoral scanner, find out what they're buying. And if dental practices, generally dental practices are just getting into 3D digital impressions, and they will need your help. You're really a service center for these devices. As much as a distributor will say they support it or whatever, the laboratory is really the knowledge center and can be the sort of Sherpa to the digital workflow, right? And to that point, you are a critical part of the digital workflow. Use this to your advantage. Control the conversation and make sure you understand what's going on and all the pieces connected to it. For dental CAD software, it can be very expensive. And softwares like 3Shape can have modules. So the core software like Dental Designer Premium, for example, if you want to design implants, you need to buy that module. Same for ExoCAD. And critically here is Model Builder is a requirement if you're accepting 3D intraoral scans and you want to build a 3D model to print, right? So find out if you have 3Shape. Do you have that module? How much is that? It's a very important consideration, right? Standalone software is becoming more common. 3-4 years ago, you had to get ExoCAD or 3Shape with the full kit of software to be able to do these cases. There are more softwares coming onto the market that are viable and getting better. And then pay per case softwares are getting much better as well. So you can, especially for like a surgical guide or a splint, you can use a design software like Blue Sky Bio and pay for just per case instead of having an expensive software and then potentially some other module fees and service fees otherwise. So if you're doing low production, definitely consider pay-per-case softwares like Blue Sky and many others on the market. Anticipate a learning curve with Dental CAD. I used to sell 3Shape for many years, and I always told everybody, make sure you take a month to learn it and grow with it. CAD software can also be open or closed. This is much less of an issue as it was many years ago, but make sure you can work with all file types and you can export STLs and everything else. And then 2 other points here: who will design the case? If you have a CAD department, is there excess capacity in that department? Do you have the skill sets to be able to take on 3D printing and all the inputs that it might require, or do you need to grow that department? And then lastly, you can outsource CAD design. So you can send it to another local laboratory if you're a practice, to your laboratory to design for you. There are milling centers that do design now, and then there are specific businesses just as design centers. So look into those, especially if CAD seems too overwhelming or if you don't have the staff or anything otherwise. I have 5 points in this next section. I'm going to go over what the easiest or hardest applications are for 3D printing, a bit on focusing on the primary use case, continue to outsource, slowly transition, and add applications. So those kind of all lead into each other. This is a list, so 1 being the easiest, 11 being the hardest, of the difficulty of 3D printing and making these appliances. And this isn't necessarily the difficulty to 3D printing, although it is a consideration. It is also the CAD software, the connected workflows. Like for dentures, it's actually very easy to 3D print and make dentures. I can do it very, very quickly. The problem is the having the right inputs for impression, the CAD software, sort of how new and developing that all is what makes it difficult, right? So this is just my opinion on what the easiest thing to do is to the hardest. So if you can see here, custom impression trays, extremely easy. Zircon's provides a software that's free to use, the CAD software. Very, very easy to print. It's fast, it's simple, easy thing, right? Diagnostic models are next, and you can read from here. Just some expectation setting. We do not have an indirect bonding tray material just yet. We have all these other ones. Focus on the primary use case. So 2 examples here. Let's just say you're a practice and you're paying to outsource them today, or you're not doing them, right? In example B, let's just say for models, say if you're a laboratory or practice, you're paying for those models to be outsourced. So somebody else is 3D printing these digital impression models, and you're paying for them as an outsource option. In example A, if you're doing dozens of surgical guides a month, or want to start doing dozens a month, start with single implant cases first when you get into 3D printing. Start with the simple stuff, continue to outsource the complex full rehab cases, right? Start with the easy stuff. Take it step by step. And on the example B, the model example, start out with the easier models. So diagnostic models, orthodontic models, those are going to be the easier models to do. Restorative and implant models, they're not too bad, but again, the CAD software is its own thing. It can be expensive. There's a lot to learn in that. Printing them is not nearly as easy as it is to just print a quick diagnostic model. It is very easy, but I would recommend maybe continuing to outsource the harder, bigger restorative models and implant models, and just focus on what you can do and feel comfortable doing. And then slowly transition as comfort levels go up, take on more complex products and production. So really step by step, right? And then focus on a primary use. So you're probably buying a 3D printer for one main application. Like 65% of all you want to do is one thing, say models or splints or guides. Focus on that one first. Then add in castable patterns or dentures or whatever it might be. So take it one application at a time. Once you get comfortable with it, then move into the multiple applications and start switching out resins and having different inputs and everything else. Next part here is the space for 3D printing. And again, this is really relevant for the Form 3B, obviously, but this is applicable to any 3D printer, photopolymerization, VAT, photopolymerization 3D printer for dental. You need a certain amount of space. And these are some tips and some things that I would recommend. Excuse my primitive drawing here. But first, this is a no-brainer for laboratories, but have an area above the steps or stages of the process for case pans and for parts to work through the process. Even though these are digital files, it's really nice to know if this case from afar is printing, or it's in wash and cure, or is it in the CAM stage. So get case pans with identification numbers and break them out into stages. So nesting or in the computer, printing, washing, curing, and then finishing, right? So have a logical workflow, know where your production is digitally and physically, because really this is about making digital physical. Second here is you need a computer, a CAM station, and really this is for retrieving, organizing files, manufacturing files, 3D intraoral scan files, and otherwise it will run your preform or your nesting software. It could be, depending on the volume, the same computer that you use for milling CAM or CAD potentially, but you will start to hit bottlenecks. You might need to start having specific stations for certain softwares, and really think of this as like your digital hub of production. And if you don't, or you're thinking about adding a computer for 3D printing, I highly recommend getting a desktop over a laptop. They're much more powerful and affordable, and you'll just, the faster the better the computer really makes the whole process easier, again, no matter what 3D printer you're using. For the 3D printer itself, make sure it's a solid table, it doesn't move, bolted to the wall is even better. A clean environment that you can easily clean. A solid table, non-porous, not a wood table, pretty much is what I'm saying, either like stainless steel or granite. it's really nice to have an area next to the printer to swap out tanks and place resin cartridges, and also consider future expansion. So if you're building this out for one printer, what would happen if you added a second or a third? If this expands rapidly, right? Make sure you're sort of planning for the future as well. Third point here is washing, curing, and part removal. So I already mentioned it earlier, but a hard table and non-porous countertop is really critical. Make it easy to clean. A splash wall in the back, so if there is a spill, it doesn't go behind the bench or the table, is really nice. As much working area as possible. And then you're going to be using scraping tools and other tools, so having like a hanger or an area for those tools to be always would be nice, or is very nice as well. And then just a couple tips on washing. In my laboratory that I've set up at my home, I have one form wash. And so what I do is I have a bucket for the first stage of washing and a bucket at the last stage of washing. So I have a very dirty IPA. I rinse and dunk the parts in it first, very briefly. Then I do a full 10-minute, 15-minute wash in my form cure, which I set it and forget it. And then I'll do a final rinse in as clean of IPA as I can keep. And if you have two washes, it just makes this process even easier. So your first dirty wash is the first one, the second form wash is your fairly clean one, and then you'll dunk finally in the cleanest IPA. And you'll move the IPA backwards through the workflow. So as the clean IPA gets a little bit dirty, pour it into your form wash, and then once that form wash, the fairly clean form wash, gets too dirty, move that to your dirty one. And the nice thing is the wash buckets, you can pull them out without having to pull out the liquid, and you can switch them between the two. So you don't have to really pour out IPA and handle it as much, which is a really nice thing and should be considered. This is a quick view from my basement here, where I have a little lab set up. You'll notice here on the top left, this is my clean IPA wash bucket, so where I'll put parts for its final rinse. And you'll also notice I have a squeeze bottle with fresh new IPA as well. So I'll do my final wash and rinse, and then I will use compressed air to dry them off. This does a couple things, especially on ditched models, removable die models, anything with internal sockets or anything like that. Compressed air really helps get out resin, and it also dries the IPA rapidly. You can, with compressed air, go directly into UV curing, so it makes that process much quicker. If you don't use compressed air, I recommend a 10 to 30 minute just bench top dry time, or a combination of both. I actually like to dunk it in fresh IPA once, air dry it, blow it out, then one more time, and then either just let it dry on my bench or compressed air to cure. Something else that's really nice is the Form Cure's rotating bottom actually comes out. So I like to bring it to my dry station and my final wash station. As I dry them, put them on the plate, and then I can just bring it over in one shot and put it right into the cure and hit go. It's just less handling, less potential dropping it or anything like that. Okay, next step here is resin and tank storage. So there's lots of different materials. You'll need the space to store those bottles or cartridges of materials, extra build plates, or build plates that aren't being used, the tanks. So for our tank system, it is really ideal to have, once a tank is used for a certain material, it stays that material. So if you're running, say, 3 different types of resins, you'll need 3 tanks at least on hand for those three resins as you switch them out, which is a very easy process. And also, you want to have a stock or an inventory here. I always like to have a couple extra tanks on hand and at least a bottle or a liter of cartridge of resin for each of my most used resins, always. So you'll need areas to store this stuff. It does not take up no space, to say the least. One note on our tank is the new Form 3B tank is much better designed than the Form 2. It comes with a container, so they stack. And you notice the orange top that prevents light from coming in, and you can store resin in this thing for a pretty long time with no problems. It stays good, and the tank just comes out very, very easily. So you pretty much put this container next to your printer. I do it with 2 hands, so I pull out the one that's in the printer, take out the one that's in the cartridge, and swap them. Very quick and easy process, and really the container here makes that a lot easier, so you can stack them and keep them all organized. Last point here, you're going to need an area to store your isopropyl alcohol or your solvent. I use a lot of paper towels to wipe build plates. Once they're out of the printer, I wash it with a little IPA and then wipe it with a paper towel. I go through a ton of gloves. You never want to handle these resins or materials with bare hands. I use a lot of gloves. Once they're UV cured, they're safe to handle, but before then, it's really this stuff, it could be very, very bad for you. So you'll need just miscellaneous space for these things, and having them handy is really, really nice to consider. Last part I believe here is cost considerations. So 7 things here I'll be going through. The first is a 3D intraoral scanner. So there's lots of options in the market. There are more today than there ever have before. That's probably obvious. And these devices range from $20,000 to $50,000. And some of them have maintenance or support fees. Some of them are open and closed. But as you can see, you can spend a lot of money on these devices. You get much different ecosystems and user experience with them. So do your homework on them. But these are some things to consider. And if you could see, you're easily going to be spending about $30,000 on one of these amazing pieces of technology. Dental CAD software for cost, 3Shape, Exocad are the best CAD softwares for dental on the market by a long shot. They can be expensive. They cost as little as under $5,000 to as much as $10,000 with all the components and modules and software. There could also be an annual license or maintenance fee, which can be up to $5,000 or more annually. So make sure you understand all that before getting into one of these CADs. I'm a huge 3Shape fan. I'm an expert in it. It's what I prefer. Exocad has some fantastic features. It's a bit more affordable. It's open. It's completely versatile in what it does, but that's sometimes a negative in some of these things, especially for who's operating the CAD software. The computer, if you don't have a computer already, some of the dental laboratory scanners and software packages come with a computer, but you will need a high-performance desktop to run this efficiently, and those can cost from between $2,000 and $3,000 as well. I have a Mesh Mixer and Blender in here because these are free-to-use softwares that are very, very useful for 3D printing and preparing raw 3D intraoral scans or dental geometry in certain use cases. CAD outsource or pay per case. I mentioned this earlier, but EasyRx is a great online CAD software for building models. Full Contour is the design service. You just send them the 3D intraoral scan or the impression, tell them what you want, they'll design it, send it back for you to make or 3D print. Blue Sky Bio is a great, and they actually have a really great portfolio now of pay per case CAD software. So check them out. But there are some sort of low entry options in dental CAD now which weren't a thing previously, and I would definitely check them out, and I would sort of take CAD, if you're not doing it today, take one of these routes opposed to diving into 3D intraoral scanning, 3Shape CAD software, 3D printing. That is a lot to take on all at once, so make the process easier for yourself. Consider these for sure. For 3D printers, they cost as low as our printer's $5,000. It's probably one of the most affordable high-performance printers in dental on the market. Some printers like the Carbon, fantastic printer, fantastic technology, is very expensive at $150,000. Professional quality, turnkey, no nonsense. They can afford that sort of price tag, but many dental businesses and laboratories cannot. Find out what the second year of support is, what extended warranties are. Having a warranty on a piece of hardware like this is always a good idea. Resin tanks, this is applicable for all 3D printers, for dental. Find out how much they are, how much lifetime you'd expect. Like for example, the Form 3B's tank is $150, I believe, and you can do about easily 5 liters in a tank. That's a lot of parts. So if you actually, put that over how many parts you can get out of 5 liters, it's like 10 to 50 cents per part in tank cost. And I actually push tanks much further than 5 liters, but don't do that. Not always a good idea, but honestly, if they're not abused really, they last a very, very long time. So next point here is resin. Resin can be a pretty big range here. $150 to $500 per kilogram or liter. You can find some budget resins on the market for around 100 or less. But the difficulty with that is, third-party resins, these printers that are open, you really have to do a lot of tinkering to get them to work properly, especially for dental. But consider there's a huge resin cost sort of divide here. Figure out what your cost per part is. Always assume that there's going to be waste. And then Preform is really nice, and many other 3D printer softwares will tell you how many milliliters the part will take to print. It's pretty easy to do the math. If the resin cartridge costs $150 and it's 1,000 milliliters, how much that part will cost. And to that point, resins are very confusingly sold in two ways: liters and kilograms. We sell our resin in liters, but kilograms, there's actually less resin than a liter. So typically a liter of resin, and they all vary based on what material they are, but a liter of resin is about 1.1 to 1.2 kilograms of material actually. So find out, that might actually put two resins or printer solutions that you're considering might put the cost per resin really similar to each other if you figure that out. And then build plates. It's really nice to have multiple build plates so you can sort of have them work through the workflow, and the printer can be running while you're working on pulling the part off or whatever, cleaning it or whatever, right? Our build plates are $100, but if you compare and shop around to other brands and options out there, these things can be very, very expensive. They really last a very long time, so they don't really need to be replaced on something they get dropped or something hit with a hammer, but it is nice to have multiple if you can. So just something to ask. So washing, there's actually a lot of different washing options out there. It's not just the Form Wash, but you can see here on the left next to the wash here, that's our finishing kit and two bucket system with sort of a basket in it. That is comes with the printer typically. If it doesn't, it's $100. You get all those tools in the wash bucket. That's a manual way to wash parts. Not that fun, but it works just fine. On the right of the Form Wash there, that is ultrasonic cleaner. So that's a potential way to wash parts. You put your part in a solo cup or something, have the ultrasonic filled with water, and run it. It's very actually quick at washing parts. Albeit a bit of a less sort of automated process because you have to time it. You cannot let those parts sit in the IPA for too long, otherwise they're going to fail. And then Carbon has a very interesting recycling solution on the far right here. Very, very expensive, but super fascinating, amazing technology. But so as you can see, you can wash these parts in solo cups for $0. Our Form Wash is $500. Ultrasonics are fairly affordable as well. And then I think the Carbon automated wash system is $15,000 over 3 years. So there's a huge range in solutions here. Post-curing is as similar as the wash. So our Form Cure is $600. Colzer sells a very good UV cure called the Highlight. It actually uses a strobe. I believe it's a halogen bulb. It's a very, very rapid UV cure parts. It actually uses, I believe, nitrogen. It has an option for nitrogen, so you can take oxygen out of the environment for UV curing certain parts, which is super fascinating. But that UV cure, I think, is around $3,500. It's very, very expensive. And then lastly here, there's the NextDent LC Cure Box, which is an option as well. That one is also very expensive. Something that's really critical with UV curing, though, is with a biocompatible resin, its indicated use and workflow will typically have a very specific either UV light or UV cure system highlighted. So to meet biocompatibility standards, you need to follow those workflows explicitly. So that's something very, very important to look into. Post-processing equipment, most laboratories will have most of the things that you need, but if you don't have a lab or you definitely worth looking into, say, the applications guides for what you're doing and the process from start to finish on how to get these parts done and finish them, what rotaries, instruments. And then, I mentioned this before, but you need to allow time and money and effort to training and staff and ramping them up in these technologies and workflow, right? this is some of the dental applications on our system. I'm just going to go through this really quickly. Really, the core of this presentation was you know, some things to consider, the cost and all that. So I'll just go through this really quickly. I've got much more detailed versions of this if you're interested elsewhere. Just go to dental.formlabs.com. But we have many different dental materials that have been tuned and optimized for the Form 3B. We've got 4 different model resins: gray, draft, model, and white. Gray is rapid production of aligners. You can see here a patient's mouth. Draft is even faster. If you have a rush case, it's fantastic. It prints a model in less than 20 minutes. Layer lines are a bit more pronounced at 300 microns, but will absolutely work in a pinch. And I highly recommend it if you're in orthodontic practice to have gray and draft as options. Model resin will work for diagnostic, orthodontic, of course, but it has been optimized and tuned for restorative models. So, fine fitting, very high accuracy, surface quality, very easy to see surfaces, anatomy and occlusion on, compared to a resin, say like white or gray, for example. Here's just a nice hero shot here of some of the anatomy that you can expect off of the Form 3B at 50 microns. White resin's great for diagnostic case presentation models. First round of biocompatible appliances: Dental LT Clear V2, our new splint material, which is fantastic. Temporary CB for temporary crowns and bridges. Custom tray for custom impression trays. There's a whole webinar on this, so I won't say too much, but new splint material, it's fantastic. Second generation material, just came out a month ago. Temporary CB resin is our first 3D printed provisional material. It's EU for now, but it's coming to the US very soon. Inlays, onlays, bridges, and veneers. Custom tray, fast printing custom trays, affordable, high quality impressions, made easy. Surgical guide resin, I've already talked about this a lot. Denture teeth and denture base. So 3D printed full dentures require 2 different types of materials, obviously, the pink and the teeth. Surgical guide, I feel like I've talked about that enough, but there's a whole video on this, but you assemble the teeth and the base to each other. Makes a very strong connection. That's actually where a lot of its strengths come from. During the UV curing process, it makes the teeth and base one. There's 6 different tooth colors, 4 different bases, as you can see here. Pretty incredible product, actually. Conclusion: unlock digital workflows using 3D printing. Really makes digital files physical. Partner with a company that provides you the support and service your business needs. This is really critical. You need to know that you need to have a team behind the product that knows what they're doing, and they can support you and make sure you're doing what you need to. Set the proper expectations. Take it one step at a time, right? You don't want to go into this assuming that you're going to do everything under the sun immediately, easily. This technology, even though we've made it really as simple as you could probably get at the moment, it is still a lot to unpack, right? 3D printing is a very young technology still in many ways. Start small, think big. So start with your primary use application, grow it from there. Focus on what you really need to do to make your business move forward. And really, 3D printing, and this is the biggest final point, 3D printing is the future of dental. There's absolutely no doubt about it. We have our first permanent crown material coming out in a couple months, and if you can imagine, this technology is just perfect for dental in so many ways, and we're still so early days in it. I guarantee in 10 years, we're going to start to see the majority of dental products be 3D printed directly. And it's just going to be ripe for adoption. And the costs are already there. It's just the workflow and the training and making it simpler and easier. It's really amazing, and to be on the cutting edge is just fantastic. Thank you so much for watching. Here's some our website down here at the bottom left, our generic team email, and then my personal email at Formlabs. Thank you so much for watching.